Hello students. In our previous video, we learned how to find surface area of combination of various solid shapes called composite solids. In this video, let us learn how to find volume of such composite solids. But before that, let us quickly recall the formulae for finding volumes of various elementary solid shapes like cube, sphere, etc. Let us understand this better using some examples. A vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of water flows out. Find the number of lead shots dropped in the vessel. Here, we will first find out the volume of vessel and then the volume of the lead shots which were dropped in the vessel, and then equate the volume of water flown out of vessel with the total volume of all the spherical lead shots dropped in the vessel. In such problems, you may get confused between the given information and about which formula we need to apply. Here, we have to use the formula of volume, and also that volume of water flown out of the vessel is equal to the number of lead shots dropped, since only that much amount of water will get displaced and the much volume shots will occupy. Therefore, volume of water flown out is equal to N into volume of one lead shot. First, let us consider the figure which can be drawn from the given details. We are given that radius of the inverted cone is 5 cm and height is 8 cm. Also, the volume of the water flown out from this conical vessel is 1/4 the total volume of water in the cone. Note that we are given cone is filled with water up to the brim. This means that volume of cone is equal to volume of water. Now let us calculate volume of vessel and lead shots one by one. Since vessel is conical, formula to find volume of cone is equal to 1/3 pi r square h. On substituting the value, we get 4400 upon 21 centimeter cube. As per data given for calculation of the volume of the water flown out of this vessel, find 1/4 of the total volume. Therefore, volume of water flown out is equal to 1/4 volume of water flown out. On substituting the value, we get 1100 upon 21 centimeter cube. Now we are given that lead shots are in shape of spheres with radius 0.5 cm. Therefore, volume of one lead shot is equal to volume of spheres, which is equal to 4/3 pi r cube. On substituting the value, we get 11 upon 21 centimeter cube. Now we have to find the number of lead shots that were dropped in the vessel. We can find them since we know that volume of the water that flows out will be equal to the total volume of all lead shots that were dropped in the vessel. Therefore, volume of water flown out is equal to N into volume of one lead shot. On substituting the value, we get N is equal to 100. Therefore, the total number of lead shots dropped in the vessel are 100.